All right, good morning, everybody. I hope you had a good Monday, Tuesday already. So just a couple of quick things before we get started on the material. Quick reminders. First of all, yesterday I posted a couple of things on Classroom that you may have noticed. So the first of those things was I provided you with assignment 9 feedback. So thank you for those of you who are completing it. It's about half in this class, so not too bad. But for the half that aren't completing the assignments, make sure you take the time to do them. I cannot stress their importance enough. They are exam type questions that you could expect, so you need to be practicing these, because if you expect to just be walk into the final and not have practice, the final will be more difficult, unnecessarily so, because you did have the opportunity to practice. The other thing that I posted was some extra practice for radicals and rational expressions. So someone in the other class had asked me for that. So I posted it for everybody. So there are some extra practice there with answer keys. So if you want to take a look at those, feel free. I apologize for only uploading the notes this morning. They were completely ready yesterday afternoon, but I was posting other things. So I just must have forgotten. So if that ever happens, and I mean ever, we only have one left, but if that happens before Thursday, just let me know, okay? I posted the list that is on the SITPROB, the narrowed down list. If it's not on that list, it's not on the SITPROB, that's it, okay? Someone had asked me for practice for radicals, just in general. It had nothing to do with the SITPROB. I hadn't started talking about the SITPROB yet. So that's just separate. If it's not on the reduced list that I posted yesterday, it's not on the SITPROB. But radicals are fair game for the final in a week from today. So that brings me to the SITPROB. So the SITPROB is tomorrow. You are to be here, and we're starting at 10:30 sharp, maybe a 2-minute delay so the first class can leave. But you need to be standing outside room 334 at 10:25, ready to go with your pencils, your memory aids, calculators. I won't have extra calculators, so do not forget, you cannot use your phone as a calculator. This is an exam. So make sure that you bring all your material and that you're ready to go 10:25 sharp, and then I'll let you in and you'll have exactly 2 hours from the time we start the exam. You will not be leaving. I repeated that before, so you will not be leaving the exam. So bring a book if you need to, and be prepared, or to take a nap on your desk if you finish early. I really don't care, as long as you're not talking and not on your phone. You can just sit there, okay? I have a sharpener in my pencil case, so you're fine. The SITPROB, everything that's on the list is fair game for the SITPROB. That's all I'm going to say. Proportions, we're going to be doing some proportions when we do this stuff. Proportions is like the Sec 2 stuff, where you just have to be able to figure out a missing value given a proportional relationship. So we did some of that yesterday. We're going to do some of it again today. I'm not going to go over it as its own entity, but we're going to be using it as a tool for other things. So I'll point it out specifically when we are using it, but other than that, we're not going over it as its own thing. Any other questions about the situational problem? That's irrelevant. Anything else? Yes, your memory aids can be double-sided. One sheet handwritten, though. If it's not handwritten, it's going in the garbage. Anything else? What do you mean? Do you have to make sure they're legal? If you're worried about it, you can show me beforehand. But when I am, you guys know the rules. Like this isn't the first time you've been presented with these rules for memory aids. One sheet, double-sided, handwritten, no printers. Like that's it. And a regular size paper. Don't be coming in with that legal size, extra long paper, or I'm gonna chop off the bottom. So when I take attendance, when I'm circulating to look to make sure everyone's here, I'm gonna be checking everyone's memory aid one by one. So if you don't have a legal memory aid, it will be mine. I will be confiscating it, taken away, gone forever, never to be returned to you. So do not come in with an illegal memory aid. Don't put yourself in that position. Just do your memory aid. That's it. So they will be checked. Anything else? Is there a specific example that you want to go over? Okay. Dun, 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 dun. All right. So the first thing is I do want to go over some of the stuff that you would like to look at. So the first thing is exponential function with the XD. So we'll take a look at that. While I'm opening that up and screen sharing, if there are any other things that you want to go over quickly before we start the new material, take the time not to post it, because if there's nothing else there, I'm just going to continue. Okay. Are you guys seeing this like black screen thing? What is going on? Because my screen doesn't show it. Stop. Let's try that again. Yeah, it was like a weird pixelation thing. Should be fixed now. Okay, so we'll go over a couple of things quickly, but then we do have to move on. Hide. Okay, so if we're talking about creating the rule, first and foremost, so I'm going to try to hit all the questions relatively quickly. So can you go over exponential function and the XD thing? Okay, so all you have to do for this is you have to identify your parameters. So creating the rule is the hardest part of that. Once you have your rule, what you do with it is the same as what you would do with the other rules. So we'll take a look at a couple of these and just practice identifying the rule. So we'll look at, this is the handout for class 10. We'll look at number 5. You bought a 6-year-old car for $4,500. Its value will decrease each year at a rate of 25%, or not each year, every 2 years. Okay, so in this case, you have your A, C, and your D. If my X is in years and my Y is my value, my A, I start at 4,500. My C is decreasing by 25%. That gives me 0.75. It's every 2 years, so my D is 2. So I have Y equals 4,500, 0.75 to the X over 2. And then you would do the same thing as you did before. How much did your car cost brand new? 6 years ago. So you would plug in -6 as your X. And then worth less than $100, you plug in 100 as your Y. Let's look at another one of these examples. We'll look at 9. The number of wolves in the wild in the northern section of this county is decreasing at a rate of 3.5 every half year. Your environmental studies class has counted 80 wolves in that area. After how many years will the population of 80 wolves drop below 15? So we have our A, C, and our D. If we define X to be years and our Y to be number of wolves, so here my A, I start at 80. My C is it's decreasing by 3.5%, meaning that I'm at 0.965. And my D, it says every half year, so my D is 1/2. So this is 80, 0.965 to the X divided by 1/2. Can everyone else see? Because I can see as an outside person. Okay, so Kayla, maybe just restart your system again because everyone else can see. Sure, I can plug in a value quickly. So below 15, don't touch it. Nothing, don't touch it. So 15 equals 80, 0.965 to the X divided by 1/2. I divide by 80. So 15 divided by 80 gives me 0.1875. You could also just write 1/2 as 0.5 if you prefer, if it makes it a little bit easier to see. You can use your log relationship. So log of 0.1875 divided by log of 0.965 is equal to X over 0.5. So if I have log of that divided by log of 0.965, that gives me 46.96. And I multiply that by 0.5 and it gives me 23.49. Kayla, try restarting our computer, logging back in and back out, because everyone else, no one, you seem to be the only one that has this issue right now, which means it's a system issue, like your computer kind of issue. So log in, log out. Make sure you're clicked. The other thing is make sure you're clicked on me. If you're clicked on somebody else, you won't see the screen. Okay. Square root function and the rule. So here for finding the rule of this square root function, so this is the square root function handout. So it's the class 7 handout. On the second page, on the first page, here, number, well, it should be 4B or whatever. You have this square root function, you're finding the rule. So as we know, the first thing we do is our sketch. So you take a point here and you have -4 and 3/4. So here it goes this way. So my rule is going to be y equals a negative x because it's on the left. Now I plug in my point, not y. We have we have 3/4 equals a square root of -4. So we have the root of 4. The root of 4 is just 2. And if I divide by 2, this gives me 3/4 is my a. So my rule is y equals 3/4 root of -x. From there, you would just plug in different values. So you would plug in the 100. So here you would get 3/4 root of -100. So that gives you 3/4 root of 100, which this is just 10. So that gives you 7.5. And then backwards, the mistake I was noticing backwards, so here I would end up, if you do 3/2 divided by 3/4, you get 2. When you get to this step, you have to square it, not square root it. So you get 4 equals -x, and don't forget about this negative, and it switches over to give you -4 equals x. So do not make that mistake. So root of, okay, so basically there's no difference. This one? I can check the answer key. What's the difference between the 1 and the 1 root of bx? There's no different. That's all. It just, they wanted you to find the b. But you could have done it this way too, and you would have found an a. It really didn't matter. Okay, trying to hit up all the questions here. In assignment 10, question 1, let me just open this. Assignment 10. Where's assignment 10? There we go. Assignment 10, question 1, what does the difference in their assets mean? Difference in their assets means, so what you're going to do is you're going to create two different rules. You're going to find two different numbers, because here you're going to find the rule for Nancy, and then you're going to work backwards. It's like exactly like the problem we did yesterday with the cars. So you create your two rules. You work backwards with Nancy to find out how much time has passed. And then you're going to plug in that time into Vanessa's rule. And the difference in their assets just means at that time, whatever you get for Vanessa, you're going to take that minus Nancy, and that gives you a difference in their money at that time. The question is 6 times a year would be 1/6. This is a compound interest question. Okay, guys, I'm really trying to do as many questions as possible, but at a certain point, we're going to end up not having a Friday review period at all. So just keep that in mind, okay? So I'm trying to hit up as many questions as possible, as quickly as possible, because if we don't get through the new material today, then we're doing new material on Friday, and that's it, that's all. So let's try to do this as quickly as possible, okay? So if we remember, compound interest problems have their own rule. So in a compound interest problem, we have, instead of having, we have A, R, and N. So for Vanessa, we have 4,000. Her interest rate is 6, and 6 times a year means 6. So for compound interest, we had this rule. No, eraser, NT, NX. We plug in our values, 1 plus 6/6, 6x. So that gives me 4,000. So remember our I'm being stupid. Remember that our R is in a decimal. So this gives me 1.01 to the 6x. For Nancy, it's the same thing. Nancy invests $5,000 at 4%, which is 0.04, and it's compounded twice a year. So you have A, 1 plus R over N to the NX. So you have 5,000, 1 plus 0.04 to the 2x. So you get 1.02 to the 2x. And in this case, you know that Nancy reached 6095. So you would solve for this. So you divide by 5,000. $1.219 equals 1.02 to the 2x. 2x. Here you would get log of 1.219 divided by log of 1.02. That's going to be 2x. So you have log of that divided by log of 1.02 gives me 10. So if I divide by 2, that gives me 5. That means 5 years have passed. So if 5 years have passed, I want to know how much Vanessa is going to have. So I just plug in 5. So you get 1.01 to the 30. and you get that she has reached $5,391.40. And then you would just subtract. No, they won't ask you to negative compound. This is compound interest. It's compound interest. It's not just compounds anything. It's compound interest, and interest means you're earning money. If it is, the reason that it is not 1.04 is because it says compound interest, and compound interest uses this formula. That's it, that's all. As soon as you see compound, you're using this formula. That's it. Okay. Assignment 11, number 1. I'm going to check it, but I don't think we've covered that material yet. That's what we'll be covering today. Yeah, you can't do this yet. We'll be covering that today. Quiz 10, number 2. So this is exactly what we just did. So you have 4,800. 3.6 is going to be your R. 3, it's every 3 months, which means your N is 4 times a year. The reason we're doing it this way is because it says compounded, and then you just plug in X is 5. So it's exactly what we just did. So take a look at that problem and try it out, okay? N is the number of times per year. So if it's every 3 months, then it's 4 times in a year. Ilaria, you're going to have to restart your computer, restart your browser, try a whole bunch of different things, because this is everyone else is projecting, so it's going to be something wrong with your system right now, okay? So just check it out and send me an email, or just put a comment here if it's still not working. I can go over one quick example of did you restart your computer as well as your browser? And are you clicked on my face on the bottom? You're clicked on my face on the bottom? And you're using Google Chrome? And you're signed into your Gmail? And you clicked on my face on the bottom? Okay, you're gonna have to try it again. I'm not sure what your issue is, but it's definitely something on your computer end, because everyone else can see me, which means you have to start again. Try restarting your laptop, try rebooting it back up, okay? Okie dokie, so I'm gonna do one quick example of greatest integer function, and then we are moving on. Okay, so this is on the greatest integer and step function handout, number 16. And then we'll move on from here, okay? Whew, trying to blitz out these questions is exhausting. All right, so a store offers its clients a rebate of $10 for every $50 that is spent. X is what the customer pays, and f of x is the rebate. So if we make a quick sketch of this just to give us an idea about what's happening with the parameters, if I spend $0, I get 0 rebate. I'm not getting anything up until I spend $50. And at $50, I'm going to save 10. When do I get another 10? At 100. And then I'll go up to 20. So now I get a general idea of what this picture looks like. So your A is 10. The length is 50. The step goes from closed to open, which means B is positive. So B is 1 over 50. We flip this, remember, in the positive because we decided it's positive. This is increasing, which means A and B are the same sign, so A is positive. So my rule is y equals 10, 1 over 50 to the x. How much will the customer pay if the purchase is, or how much will she save if the purchase is made before the rebate amount is equal to 321? So I would plug in 321 as my x. So here I would get y equals 10, 1 over 50, 321. So here you would get 321. So you get 6.42. The questions on the side, A is what? Remember, A is the step length. So it's the A is the counter step. So it's the jumps that we are making. B is the flip. Step length and V, we flip to get to one another. So 50 over 1 flips to 1 over 50. So we're back here. This is where I noticed a lot of mistakes in the assignment. When I take this, if I'm changing the brackets, that means I'm taking the greatest integer of that. That becomes 6, which means I'm going to save $60. When you're doing this, you should not end up with a decimal. C, we saved $80. No. Yes. No. This is not a closed dot. This has nothing to do with closed or open dot. This is when we're solving for closed and open dot is the x value. So here I divide by 10. So I get 8 is 1 over 50x. Remember, we drop the brackets and solve. So 50 times 8 is 400. What do you mean the other way around? It never goes up. You never round up with greatest integer. Nope, has nothing to do with that. A greatest integer is we round down, period. Okay, so always, always, always round down. Here is where we get into the step open to closed. So this is my solid dot. So I know that the step is going from closed to open and that the length is 50. So the 400 starts this off and I'm going to add 50 to give me 450. And I stress this again, you don't get full marks unless you have the whole step. We good to go? Exactly. If B is positive, the first dot is closed. I would subtract 50 if B had been negative. If B was negative, then my step would have been like this, and the 400 would have been the end, and I would subtract 50 to give me 350. What do you mean even in integers? I don't understand the question. Okay. Okay, so we'll get started. I'll just answer this last question. What is the D variable if in exponential if the problem says doubles every 30 minutes? It depends on what you set your X as. If you set your X as minutes, then D would be 30. But if you set your X as hours, 30 minutes is half an hour, so your D would be half. And we did a problem like this where I did it in minutes and in hours. Your answer doesn't change, but if you use minutes, then you're plugging in minutes as your X's and solving for minutes. And if you use hours, then you're plugging in hours and you're solving for hours. Okay? All right. Lots of problems today. I mean, like mathematical problems that we went over. If you use compound interest, you're always, there's no C. If you see the word compounded, you're using the formula, this formula. So then in that case, if it was 5% compounded every 4 months, you would get R is 0.05. Every 4 months means your N is 3 times a year. So you would get 1 plus 0.05 divided by 3 to the 3x. We good? Okay, so yesterday we were doing probability. We left off here. So this is page approximately 6, 5, 6, 7 potentially. So at the top of the page says laws for probability, probability of Venn diagrams. So we started talking about different probability things, and we had these different rules. So we just quickly were looking at the rules. So just things like if we have two things that are complements of each other, meaning they create the whole solution set, then if we add up those probabilities, it should give me 1. And when I have the probability of the universal set, it's 1, and the probability of the empty set is 0. So we're going to look at number 4. The probability of A or B is going to be equal to the probability of A plus the probability of B minus the probability of their intersection. So if we just go back to an example here, okay, if I take this example, okay, so I want the probability of A or B. So if we remember, the probability of A or B is the whole circle doubled up. So you would think that we would just add the probability of A and the probability of B. But if I add the probability of A, I get 1, 2, 3 out of the total of 6. And for B, I get 1, 2, 3 out of the total possibilities of 6. So this gives me 6 over 6, which is 1. But that can't be true because I have one value out here. So it's not certain, it's not 100% that it's going to fall in here. And the reason that this isn't, what happens here is if you just do this, this value ends up getting counted twice. So what you have to do is you have to minus the probability of their intersection. That way you're only counting it once. So then I would minus 1 over 6. And that would give me 5 over 6. Does that make sense? So when you're finding the probability of their of A or B, you have to find, you do the probability of A plus the probability of B minus their intersection. That way you don't count this twice. The numbers represent, so in this problem, the numbers represented a roll on a dice. So it doesn't represent a weighting. It's not like a 1 is worth 1 and a 6 is worth 6. They're each one outcome. So a 4 is still one outcome, right? Exactly. So we're not adding the values. So 4 isn't worth 4, it's one outcome. So that's why when I have in A, I have 1, 2, 3 different outcomes. It's just adding the outcomes, exactly. The number of outcomes that we have. 2 other rules that we have. So we remember this was the difference we were subtracting. So this meant A subtract B. And what this is we take the probability of A and we take out the intersection. And same thing with B. If we want the probability of B without A, we would take the probability of B minus the probability of A. So in our example here, just to be clear, if we're doing probability, probability means how many outcomes in A divided by the total number of outcomes. And since we're doing the probability of A or B, we take the probability of A, which is the outcomes in A divided by the total number of outcomes, plus the probability of B divided by the total number of outcomes, minus the probability of their intersection, which is the outcomes in the intersection divided by the total number of outcomes. If Yep, so this means or, this means and, which is the same thing as the intersection. Okay, so if I wanted the probability, in this case, of A minus B. This means whatever's in A without the things that overlap with B. So according to our rule, we take the probability of A minus the probability of their intersection. So if we look here, the probability of A, there are 3 values out of a possibility of 6. In their intersection, we just did that. There was one outcome out of 6. So that gives me 2/6. So if I look in here, if I take A without B, there are 2/6. So that's what we get. So this just puts it in a more formal sense where we actually have a rule to do this. In a Venn diagram, if they just asked you for A without B and you just circle like I just did there, that would be fine, right? If I just said, oh, look at A without B and there are 2/6, that's fine. But if you're given different probability values, you may need to use the formula. Good? The 5, A without B, means we want everything in A that's not also in B. So this 5 doesn't count for us for this purpose. A subtract B. So whatever's in A minus whatever's in B. Because here, this is the probability of A. So for this part, we're taking anything that's in A. And then here, we're subtracting the intersection, which is 1 that's also in B. Like I said, if you just do this without using the formula, it would just be 2/6. But the formula says it's the probability of A, which is 3/6, minus the probability of their intersection, which is 1/6. In the end, it ends up being the same. One more quick rule. The one we just did before, where we have the A or B. If they're mutually exclusive, meaning there is no events overlapping, then this is 0, right? If there are no events overlapping. So if they're mutually exclusive, we just add those two probabilities. For instance, I will get to your question in a second. So for instance, if I had if I have A here, which was 1, 2, 3, B, which is 4, 5, and for some reason 6 was on the outside, whatever created this. In this case, if I wanted, oh my goodness. Why I hate this thing. If I wanted the probability of A or B, this would be the probability according to our rule minus the probability of their intersection. I have 3 events in A out of a total of 6. I have 2 events in B out of a total of 6 as well. But this is empty. There is nothing in their intersection out of 6 possibilities. These notes are filled out. There's nothing missing. All you should be doing is writing down what I'm writing down. So these are filled out, they're posted. So when I do this, I get 5 out of 6. This just becomes 0. So because they have no events overlapping, this just goes away. Okay, so those are just rules that you should have on your memory aid. What are we using Venn diagrams for? So we're first going to just look at an example quickly of using Venn diagrams. Oh, sorry, I missed the question. If we just looked at the diagram and gave the correct answer just by seeing the diagram, would we get full marks? It depends on what type of question it is. So if you're given the diagram and it's a multiple choice, for sure. If you got this as part of a part C question, chances are you'd have to make the diagram yourself. So if you made the diagram yourself and then answered it from the diagram, that's fine, as long as I see where it comes from and you don't just pop the number out of your head. So for Venn diagram problems, you're going to set up the Venn diagram, you're going to fill it out, and then you're going to calculate what you don't know and then figure out what the question is asking you for. For instance, there are 200 students that had to write an English and math exam. So we'll say E is passed English and M would be passed math. So now we're going to figure out how we can fill this out. So we have 60 students passed both exams. So we always start with the intersection if we're given it. 60 passed both exams. 20 failed both exams, so 20 goes on the outside. "48 students passed math but failed English," meaning that that is just the M. I now know, well, I know that there are 200 people total. So if I subtract the 60 and the 48 and the 20, that will give me the students that passed English but didn't pass math. So 200 minus 60 minus 48 minus 20 gives me 72 in there. The question then asks, what is the probability that a student passed English? So we want the probability of a student passing English. So that is everything in the English. So English is actually 72 plus 60, which gives me 132. So I have 132 over 200. So that gives me 33 over 50, or 66%. So we're going to be filling out Venn diagrams to help us answer questions. Okay, so we're going to keep on going because we're going to do this, although there are some more examples. We'll do number 3 quickly, okay? Number 3, we have event A and event B. We have the probability of their intersection is 0.4. We have that event A is 0.7. So if I take the 0.7 minus the 0.4, that gives me 0.3. And that's what we have on the outside here, on the outside of the intersection. I do the same thing for B, 0.5 minus 0.4, that gives me 0.1. That goes here. And to find what's on the outside, since it should add up to 1, I would do 1 minus 0.3 minus 0.4 minus 0.1. That gives me 0.2. That goes on the outside. What is, they want AUB, so the probability of AUB, we're going to add these 3 up. It has to equal 1 because probabilities have to sum to 1. This is a probability of B. So the probability of B is 0.5. The probability of A is 0.7, and the probability of their intersection is 0.4. And probabilities always have to sum to 1. So if I have this probability, I'm going to add these three things up. And then I'm going to get 0.8, which is the same as 80% if you want to write it as a percent. These are probabilities, okay? Probabilities. So the probability that I'm going to land in A is 0.7. So all of this together, it doesn't matter how many things I have. The probability of getting in here is 0.7 or 70% or 7 out of 10. Same thing for B. The probability of me getting in here is 0.5. So if I have 25 things, or if I have 30 things, let's say 30 different things, 15 of them will be in B. Half of it, 0.5, the probability. Their intersection is 0.4, which means doesn't matter how many things I have, these are probabilities. So I can just put the 0.4 in there. And probabilities have to add up to 1. So we have all of these things that add up to 1. We also could just do this. We have a rule for this. If you're not getting the Venn diagram, just use the rule. You're given all of these things. So the probability of A is 0.7. The probability of B is 0.5. The probability of their intersection is 0.4. And if you do this out, you get 0.8. So you didn't even have to use the Venn diagram if you find it too confusing. Because those are probabilities, not outcomes, not number of outcomes. They're probabilities. But we could still represent it by a Venn diagram if we so choose to. Okay. What are we going to be using this for? This is a tool for us, and we're going to be using it for conditional probability. Conditional probability often comes up as a part A or part B question. So conditional probability means we have different events that are happening, and we have the probability that we know something happened. And given that probability, given is going to be your super important keyword here. It doesn't appear in all of the conditional probability questions, but a lot of them. So given that something happened, so we know that B happened, what is the probability of A happening? So the condition of A is that B already happened, or we know B. So there are two different ways to calculate this. We take the number of things in their intersection, A and B, and we take divided by the number in just B. So see here we have the B in the second given B, so B goes on the bottom. Or we take the probability of their intersection and divide by the probability of B. Chances are we're going to be using this one a lot, but you could use this one if that's what you're given. It's the same thing. So the first way we're going to be doing this is using a Venn diagram, and then we're going to be using something else. So first thing we're going to do is construct the Venn diagram. So we're going to pass the English test E, and we'll call the biology test B. So we have E. 12 passed both tests, so I put 12 in the middle. 16 no, sorry, 18 passed the English. So if there's already 12 there, I need 6 additional. And for biology, 12 passed already. I have 16 here, so I need 4. And on the outside, I have 25 students, so I'm going to subtract 6 and 12 and 4. That gives me 3 to go on the outside. Find the probability that a student passed English given that he passed biology. So the one that is given is the one that we know, and that goes second. So this is, we're going to use the number one. So the number in their intersection divided by the number in B. The number in their intersection is 12. The number in just B is 16. So if we know that a student passed biology, the probability that they also passed English is 3/4. Oh, we're going to do at least 2 more this way, and we're going to do like 4 more with the other way, so don't worry. No problemo. At Central Academy, there are 20 students in a physics class. 18 students passed their optics test. 16 students passed their mechanics, so we'll call M mechanics. And we'll call O optics. And we mean passed these classes. We have a total of 20. So 15 passed both. Total of 18 passed optics. Since I already have 15, I have 3 out here. 16 passed mechanics. I already have 15 here, so I have 1 here. The outside is going to be 20 minus 3 minus 15 minus 1. That is going to give me 1 on the outside. What are they asking for? They want the probability that a student passed their optics test. Change this to given. Big typo in there. Given that the students passed their mechanics test. So we have the probability of passing optics given that they passed mechanics. So number of the intersection between the two divided by the number of mechanics. So how many do we find in the intersection? We have 15. How many are in mechanics in total? 16. So this is done. And if you want to convert this to percent, so if we know that the student passed mechanics, there's a 93.75% chance that they also passed optics. Okay. At a college, 70% of students passed English, 60% passed French, and 50% passed both. So passed English, F can be passed French. So we start with intersection. We are dealing with percents, so our total is 100%, right? We don't even care what the numbers are right now. We have percentages, and we can treat this the same way. 50% passed both. 70 passed English. I already have 50, so I need 20. 60 passed French. I already have 50, so I need 10. What's going to be on the outside? 100 minus 20 minus 50 minus 10. That gives me 20% passed neither. Find the probability that a student passed French given that they passed English. So the probability that a student passed French given that they passed English. So this is the number of French and English intersection over the number of English. So in the intersection, I have 50. In English in total, I have 80. So this is the same as 5 over 8. Which is the same as 62.5%. English is everything that's in English, which includes this and this. Oh, it should be 70. Hello. Wake up. 50 over 70. Good catch. Thank you very much. So that's 5 over 7, which is 71.4%. Thank you. So the other formula says that the probability of F given E is the probability of their intersection divided by the probability of English. So I'm going to show you that you end up with the same thing. The probability of their intersection is 50 out of a total of 100. The probability of English is 70 out of a total of 100. Okay, so if you type this in with brackets in your calculator, 50 divided by 100 in a bracket, divided by 70 divided by 100, also in a bracket, you get the exact same thing. You get 5 over 7, which is 71.4%. So it doesn't matter which one of the formulas you use. Obviously, if you have stuff that you could just use the number, it's much easier. But if you only have the percents, you could do it that way as well. How do we feel about this? Not too bad? We're going to do a couple of more conditional probability problems, but they're going to be, the information is going to be presented to you in a different manner. So we good? I'm interpreting your silence as, please continue, miss. Thanks, guys. So entry tables are another tool to help answer conditional probability questions. Your job, if it's not already given to you, will be to set up your table. So you're going to have two different types of variables, and it's going to be very obvious what type of variables you have. So on one axis, you're going to have one variable, and on the other axis, you'll have the other. You'll have a total column, and you're going to fill in your values. Okay. A middle school in Chicago has 400 students. 240 are girls. 70% are in grade 7. The rest are in grade 8. Okay, so it's a contingency table-ish, yes. So in the sense that you have one variable up here, you have the other variable this way, and you have different values. It's not a contingency table necessarily in the sense that you don't have, you have totals and the variables are actually dependent on each other. So it looks the same, but the way we fill it out is different. So I have girls and boys. So that's going to be one variable this way. Okay, so I'll have girls and boys. And always here I have my total, and here I'm going to leave it blank. The other variable that I have kids that are in grade 7 and kids that are in grade 8, and I have my total. So what happens here is this box is going to be the girls that are in grade 7. This box will be the girls that are in grade 8. And this box will be the total number of girls. This will be the total, the boys in grade 7. This will be the boys in grade 8. This will be the total number of boys. This is going to be the total number of grade 7s. This is going to be the total number of grade 8s. And this is going to be the total. So all of these values depend on each other. So let's take a look at how we fill this out. So total, I have 400 kids. This is important for me. I know there are 240 girls. If there's 400 total and there are 240 girls, how many boys are there? 160. 70% are in grade 7. So 70% is how many over 400? This is a proportion calculation, okay? So that's what I mean by proportion. So I have 70 over 100 times 400, and that gives me 280. So what this means is I have, shift this way. What this means is I have 280 in grade 7. The rest are in grade 8. So I have 400 minus 280 is 120. Just change this question to a grade 7 boy. Okay. The probability of selecting a grade 7 boy at random is 1/4. So I have 1/4 of 400. That gives me 100. That is the number of grade 7 boys. From there, I can fill everything else out. If there are 160 boys, 100 of them are in grade 7. I have 60 in grade 8. If in total in grade 8, I have 120 kids, 60 of them are boys, that means 60 of them are girls. If I have 240 girls and 60 of them are in grade 7, 180 of them are in grade, if 60 of them are in grade 8, then 180 of them are in grade 7. So now I could say, what is the probability of selecting a grade 7 given that I know it's a girl? So I just pick out a student, I know it's a girl, what is the probability that she's in grade 7? So I take the number of grade 7 intersected with girls divided by the number of girls. So the number of grade 7 girls is 180. The number of girls total is 240. So 180 divided by 240 gives me 3/4, which is 75%. So if I know that the student I've selected is a girl, so given it's a girl, what is the probability that she is in grade 7? 75%. So I just added this on. What is the probability of a student being grade 7 given that I know she's a girl? I just added this on. So the longer part of these type of problems is actually filling out the contingency table. I'm going to scroll. All right, number 2. In a class of 30 students, we have 3/5 of the students are boys. So we have, what is that? Go away. Cat photos. I don't sign cat photos. Silly. We have girls and boys. And total. We leave this blank. What else do I have? I have right-handed and left-handed with my total. There are 30 kids in my class. 3/5 of them are boys. So 3/5 of 30 gives me 18 boys. If there are 18 boys, then there are 12 girls. Remember, each of the columns and each of the rows have to sum up to give me a total. The probability of selecting a student that is right-handed is 4/5. So 4/5 of the total of 30 gives me 24, which means that I have 24 right-handed kids and 6 left-handed. The probability of selecting a right-handed girl at random, so 1/3 of this, gives me 10. That represents the right-handed girls. Now, if there are 12 girls and 10 of them are right-handed, 2 are left-handed. If there are 24 kids that are right-handed, 10 of them are girls, 14 are boys. If there are 6 left-handed kids, 2 of them are girls, 4 of them are boys. If a boy is selected, what is the probability that he is left-handed? So the probability of being left-handed, given that he's a boy. So I have the number of left-handed boys intersected divided by the number of boys. So the number of left-handed boys is 4 divided by the number of boys, which is 18. This gives me 1/9, which gives me 22.2%. Two over 9. 2. I like to do these things just to make sure you're paying attention. Oh my goodness. Go away. Okay. One more. We did almost 40 minutes of review at the beginning of the class. That's what the time was for review. So like I said, if we don't get through this stuff, we won't have any time to review for the final. So the reason I tried to hit up all the questions as much as possible at the beginning of class was to make sure that we had the review we needed, and then we can go from there. If you're having difficulties or if you have questions, you have 2 different options. One, first and foremost, I'm always available by email, and I will try to be available decently late tonight to answer emails, but it will not be answering any emails tomorrow in the morning, or like just one round. Or you can go back and rewatch the videos. Always remember that you can go back and watch the YouTube links. You can just watch the classes over, just pick out the points that you had difficulty with or on specific classes, okay? All right, so this is freezing. That's fabulous. There we go. No, there won't be any of this on the SIP problem. Okay. We were at the third example here. Oh no, not this far. Oh no, we're not on 12. Sorry. Got it. There we go. Okay. All right, so we have 200 students in grade 10. We have boy and girl. And then we have English and French. We have 200 kids total. Oh, you're being a pain. No, it doesn't matter where you place things. No, you could have your boy and girl this side and English, French, and you could have them switched. It really doesn't matter because your numbers will be important. So you have a boy at random is 60. So you have 60% of 200. So that gives me 120 that are boys. So 120 are boys. That means I have 80 girls. 25% speak French. That means 50 speak French. So 150 speak English. The probability of selecting a French-speaking girl at random is 15. So that gives me 30 for French-speaking girl. From here, I can fill the rest out. If I have 80 girls, 30 speak French, 50 speak English. If I have 50 that speak French, 30 are girls, 20 are boys. If I have 150 English, 50 are girls, 100 are boys. If a girl is chosen at random, what is the probability that she speaks English? So we know that it's a girl. And we want to know speaking English given that she's a girl. So this is the number of English intersected with girl divided by the numbers of girls. So English girl gives me 50. Total for girls gives me 80. So this gives me 5/8, which is 62.5%. So if I have a girl, there's a 62.5% chance that she speaks English. How do we feel about this? Do we need to see one more example, or are we feeling pretty confident? One more? Sure. So this is on the handout. So this is yesterday's handout. Class 11 handout. Number 10. Okay, just to quickly go back. This is the number in their intersection and the number of just girls. So the total, their intersection between English and girls is the column or the square that's English and girl. And the number of girls is the total number of girls. So you're using the intersection of the two things that you have divided by the total number of the thing that is given. So hopefully we'll do one more example. Maybe it'll become a bit more clear. So here we have this contingency table to fill out, but they don't, like, all you have to do is fill out, play the numbers game. I can play the numbers game. 45, 35, so that's 10. Here I could get 175 minus 75 minus 20 minus 10 gives me 70 people here. 400 minus 130 minus 80 minus 45 gives me 145. 2080 gives me 60. 145, 70 gives me 75. 130 and 75 gives me 55. And 400 and 175 gives me 225. So a resident is chosen at random. What is the probability that this person is between 80 and 85, given that he is a male? So now I'm going to take the intersection we're going to take the intersection of the 80 the intersection of the 80, 85 and male, and the total number of males. So the intersection between 80 and 85 and male is 75. The number of males in total is 225. So if I do this, 75 divided by 225, this gives me 1/3, or 33.3 repeated percent. So on this handout, you have a whole bunch of different questions that have to do with conditional probability. A lot of them, so here for these ones, you don't even have to construct the table. They give it to you, so you just have to do the last step. In questions like 4, you have to create the table. 7, you have to create the table. 8, you have to create the table. 9, you have to create the table. But these are exactly like the problems we just did. So make your table on the side and use this information to create your table and then answer the question. After that, you've got some practice on Venn diagrams and conditional probability. So you can do all of those to help you with that. And assignment 11. The forms, these are examples of part A questions. So here's, given that an employee chooses work full time, what is the probability that he's a man? Given this would be a Venn diagram. And here you fill it out and then you go for it. So that's all conditional probability. So that's yesterday's class. And the same thing with this. This, you make your table. Here you're going to be using Venn diagrams with information, and here it's a thinker question with probability, with given, so conditional probability. Okay, so you can take a look at all of those now, not now, but whenever you finish prepping for your SIT prob. The question on the side is, will you put up any practice sit probs or past sit probs used for TS classes? The answer is no, because practice sit probs don't always help. They either make you underconfident or overconfident. The best tool for you, or the best idea for you, is to practice as much as possible the tools that you need, because situational problems, as long as you have the tools you need, you should be able to get through the sit prob. It doesn't help you to practice them necessarily in a situation, and it's very hard to match the situation to those topics, right? So I'd have to have another sit prob that's exactly the same kind of sit prob using those topics for you to practice, which is nearly impossible. So the idea is to practice those as much as possible. Analytic geometry is there. Go through your analytic geometry tools. Practice using distance, practice using division point, practice using perpendicular lines, parallel lines, all of that kind of stuff, okay? So we have to continue, so we have a bit left to cover today. So we are now going to be on class 12 notes. So the first thing we're going to look at is just the reverse of conditional probability. So we had these formulas, okay? Probability of A given B is the probability of the intersection divided by the probability of B. So I can just rework this formula to say, well, if I want the probability of their intersection, if I'm looking for this, I can just move this up. Same thing if I just reverse these things. It doesn't really matter because the intersection is still the same. I just get the probability of A at the bottom. So if I want the intersection, I can just move this up. Chances are you don't usually get questions like this, but you just have to know that you can manipulate this. If you're given the probability of a given situation, you can do this in reverse. So those are two formulas that you can just put on your memory aid. So let's just take a look at this problem. So the difficult part of this is identifying what you have. In a factory where bolts are made, a machine M provides 40% of the total production. So we'll say M is machine M, and 10% of the bolts produced by machine M are defective. So we'll call D a defective bolt. Okay. So from this, we know that 40% is machine M. So M is 40%, which is just 0.4. 10% of bolts produced by machine M of defective. So given that it comes from machine M, how many are defective? That's 0.1. So it's 10%. They're looking for the probability. So this is a probability of M. P of M, just there. They're looking for the probability that it comes from M and is defective. So they're looking for the intersection. I'm just not doing, my writing is not very clear. M and the intersection. So we saw from our formula just before that the probability of their intersection is the probability, the conditional probability, times the probability of this one. But I have both of those things. So I have 0.1 times 0.4, and that gives me 0.04. So in this case, the hard part of this problem is identifying what information they give you, okay? So this is the formula that we just looked at that says if I have the conditional probability and I have the probability of A, I can find the probability of the intersection of A and B. Just using this formula. So in this case, I know the probability that it comes from machine M, it's 0.4. I know 10% of bolts produced by machine M are defective. So probability that it's defective, given that it comes from machine M, is 10%. Now, they're asking for the probability of their intersection. What is the probability that it comes from M and meaning intersection is defective? Well, according to our formula, if I want the intersection of these two things, I can take the conditional probability times the probability of the second thing, the given element. So I know this is 0.1. I know this is 0.4. That gives me 0.1 times 0.4. So the probability of their intersection is 0.04, sorry. So this is just a less likely type of question that you could get. But I wanted to take a look at it just in case. It is a little confusing. This type of question is confusing. The hardest part of this type of question is literally just identifying what information they're giving you. So this part was the harder part. 10% of bolts produced by machine M are defective. Okay, so we're only going to have time to do one more little thing before class is over. Independent events. So we were looking at conditional probability. So when I have conditional probability, what this means is the intersection of two events are independent, meaning that there's no overlap. Like if I flip a coin and I toss a die, if my event A is rolling a 6 and my event B is getting a tails, then A and B don't influence each other. I can get a 6 and a tails, or I can get not a 6 and not a tails, or I can get not a 6 and like it doesn't matter because they don't influence each other. Whereas if we have marbles in a bag, sometimes they do, right? So if I'm taking marbles out of a bag with or without replacement, then one thing is influenced by the other. Because if I'm not replacing the marble, then what I get on the second step is influenced by the first. So these are some rules, probability rules, to tell us whether or not two events are independent. So this again should go on your memory aid. So before we do the problems, it's actually easier for us to see if two events are independent if we have created a tree, because we need to know these are ways of verifying if our events are independent. Okay? For instance, if their intersection is the same thing as the probability of just event A times the probability of just event B, then those two things are independent. So for us to know this, we need to know this. We'll just take a look at number 1, okay? A bag has 20 marbles that are red and 30 blue marbles. You draw a marble from the bag, then draw a second out with replacement. So I take a marble out, I look at it, it's red or blue, I put it back in the bag, and I pull out another marble. So first and foremost, the probability of blue is 30 out of 50 marbles are in my bag. So I have 20 red, 30 blue, that gives me a total of 50 marbles. The probability of red is 20 over 50. Now, find the probability of obtaining a blue on the second draw. What do you think it is? So just to reiterate, I take the marble out of the bag, I put it back in the bag, and now I want to know what the probability is of me getting a blue. It's 30 over 50 because I haven't taken a marble out, I haven't done anything to the bag. So the second step is independent of the first. Because that first step does not influence what I'm going to do on the second step at all. It didn't matter if I got a blue or red on the first step. My probability didn't change. So those two things are independent. The first step and the second step are independent of each other. So you just have to have a knowledge or understand the meaning of independent. Like you know what the word independent is in an English sense, like how you use the word. I'm an independent woman, you hear that in songs, you know what the word independent means, but in terms of probability, it means the same thing. Independent means if I'm saying I'm independent, I don't need anybody else, I'm not influenced by anybody else. When probability, if events are independent, they're not influenced by other things either. Okay, so we'll stop here. We still have a bit of probability. We have 0 time to lose on Thursday, okay? 0 time. Because we have to finish the probability thing that comes up as a Part C question very, very often, so it's super important. And then we have one stats thing left to look at as well. And then that'll be the end of new material. And during the stats thing, I'll provide notes for the review of the stat stuff that you did in CST, but we still do have new stuff to cover in stats. That'll be the end. And then if we finish all of that on Thursday, Friday's period will be review, going over exam type problems and going over assignment type problems. Okay. If there's anything between now and tomorrow, send me an email. I'll be trying to be on top of my emails as much as possible today and tonight. Other than that, obviously I won't be accessible like if I'm eating dinner or whatever, but for the most part, I'll answer as quickly as I can. Other than that, become prepared, be here 10:25 with everything you need. Don't forget anything, no cell phones, get ready to throw them in your bag beside the room, okay? I said put this on your memory aid. I did not mean for the SIP prob, I mean for the final exam. Okay? So again, the memory aid for the SIP prob is just those topics that I posted the condensed list yesterday. Any other questions? If there are no other questions, have a great afternoon. If you have any questions, feel free to email me, and good luck studying. I will see you tomorrow.